Find the inverse function of f of x equals 4x, then verify that both f of f inverse and f inverse of x are equal to x. The identity function is just x. So the first thing I'm going to do is sketch my graph very quickly to check with the horizontal line test. So I know my graph is going to have a y-intercept of 0 and a slope of 4. So this is a quick sketch of f of x equals 4x. And I can see no matter where I draw a horizontal line, it will hit this function once. So this has an inverse by the horizontal line test. So that was step one. We checked to even make sure if it's worth our time to look for an inverse algebraically. So now I have f of x equals 4x. The first thing I'm going to do is replace f of x with y. Y equals 4x. Then I'm going to interchange the roles of x and y. So that means x equals 4y. Now I'm going to solve for y. X over 4 equals y. And now I'm going to replace y with our new notation. F inverse of x equals x over 4. And that makes sense because if I'm multiplying by 4 in my original function, my inverse should be doing the inverse operation of dividing by 4. So this is my inverse function. Now I am going to verify. So the first thing I need to find is f of f inverse of x. Well, that's going to be 4 times f inverse of x. So that is going to be 4 times x over 4. And we can see that my 4's cancel, and I'm left with my function x, which is my input. Now I'm going to check the opposite way. F inverse of f of x. Now I'm plugging f of x into my inverse. That's going to be f of x over 4. But remember that f of x is 4x, and 4 over 4's cancel. So I am left with x. So therefore, f of x and f inverse of x are inverses. So we used this special rule of doing the composition of our two functions to show that all of the operations cancel out, just to leave my input, to verify that they are inverses of one another.